Hello and welcome to episode 3 of the 8590 tutorial series on programming for FIRST Robotics. Today we are going to be talking about complex motor systems, and this should be a shorter video, and it's really just going to be about the specifics and what you need to do when you are setting up something beyond just making a motor spin. So the first thing I am going to cover is the master-follower relationships, right? So often all you need is one motor to spin one thing, and it's very simple. But in some cases, you're either trying to carry something very heavy, or you are trying to make something go very fast, and for whatever reason, you need multiple motors working on one task. And when that happens, it's very nice to have two motors that can synchronize with each other and go at the exact same speed, right? Because if you were just trying to have both of them go at the same time in every situation, it might be a lot more difficult than just setting up a master-follower relationship. You can also see here we are creating a relative encoder. I'll talk about that later. That's just another thing we're going to talk about today. So the first thing is the master motor and the follower motor. They both need to be, of course, declared, and then we initialize them. And it's the same as anything that we've done with motors before, right? We have unique IDs. We have the master motor ID, the follower motor ID. Again, both brushless. We're using Neos. And we have configs, right, or configurations. And this is going to be different than maybe a lot of past code you have seen from our team, at least anything before 2025, because Rev Robotics just made a lot of changes in 2025, and so a lot of code you see before then is not up to date. This code is up to date as of 2025. You can see we have a SparkMax config, right? That's kind of where we store a lot of the data and settings for our motors, right? And the motor controller and the motor configuration are declared as separate objects. So you can see this is the kind of format, right, where we have our master configuration. In this case, we just set it to be inverted and have it be true. That's kind of just arbitrary. We're not doing this for any specific purpose right now. We also have the idle mode. The idle mode is how your motor acts when you're not running it, right? So in some cases, you might have your wheels, and let's say you want to make it really easy to roll your robot around the ground, right? You would then want to have your idle mode be coast, right? So that they can easily spin, right? But let's say you have your motor and you want it to carry something. You want the thing to stay in the air without falling. Depending on how heavy that is, you might need to just run your motor in the opposite direction. But typically, if it's light enough, you can just set your idle mode to brake, and you will at least face some resistance when trying to move that motor. Moving on, we then create the follower configuration, right? So here you can see again, have the idle mode set to brake, and we have the current limit. The current limit is a way of deciding how much force you will allow your motor to do. For example, in the most recent year, we had an algae remover, and it was essentially just an arm that would spin into the algae component of the game, and it would remove it, right? And we found an issue where often we would try to go down on it, and there would be too much resistance, and we wouldn't be able to push it out of place, right? And the fix for that was to heighten the current limit, right? As the current limit goes up, it allows for more resistance. However, you also want to not make it so high that you are going to burn out motors or do anything dangerous. So there is something to be said about researching how you should find your limit. But right now, we are trying to do a simple introduction to these complex motor systems, so we're not going to go into all of that. Just know that is generally the purpose of the current limit. Moving on, we can also see that we have the follow attribute, and this is what makes the follower follow the master, right? Everything that happens to the master also happens to the follower. It's pretty simple. Something that's also useful is, say we have a flywheel. That's a mechanism that is meant to shoot a projectile, right? We might have two motors on either side of that. And if we have it on either side, but we still want them to go in the same direction, then it's very important to have one be inverted from the other. So in this case, we might say the master is inverted, but the follower is not. And in this case, they will spin in opposite directions, but at the same speed. Moving on, we then have to configure that configuration to whatever motor controller we are talking about. And this is pretty simple, right? You see the master motor, we configure it to the master configuration, and we then set the reset parameters and the persist parameters. These should pretty much always be the same when you are doing these configurations, and you shouldn't worry too much about them. But of course, you should probably just research anything I talk about more, because that is the best way to learn the ins and outs of FRC and to become really comfortable with it. I had also mentioned earlier we had this relative encoder, and what this is physically is an encoder that is separate from the motor controller but can plug into the motor controller and act as its own encoder. Remember, we talked in the last video that encoders are just a way of tracking rotations. So you can see in this case, if we're plugging it into the master motor, right, then we're going to say master motor.get alternate encoder, and that'll configure the data right there. If we wanted, we could also change it to the follower motor if we were simply, plugging it into the follower motor. We could do it either way. And then for that alternate encoder, we then have to, of course, set up a little bit of configuration. You can see we take that master configuration. If we are using the master motor, I would have to change this to follower config if I had changed it to follower motor, as I had done right here. But after I did that, I could simply say set SparkMax data port config. And then, of course, we have the position conversion factor. This we talked in the last video about, and it should have just the rate at which those pulses turn into distance. And then just to make it so that this will run, we have, of course, something that says run motor system, and we set the speed of the master motor to 0.2. And this will also set the follower motor to be, in this case, negative 0.2 if this is inverted from what the master config says. So in this case, they will spin at the same speed, but in opposite directions, which of course will help something go through and come in contact with both of them if they are on either side of it. And then anything else in this project that you see is just commands that are all meant to be run through the robot container. And like I said, short lesson. Again, all code is available on github.com/FRC8590. And that's it. That's today's video.